In July 2024, reports surfaced indicating that Japan is planning to transfer advanced turbofan engine technology to India. Notably, this involves sharing research and design insights, not the delivery of actual engines. While such collaborations are not uncommon between friendly nations, the scale and depth of this potential transfer have sparked debate among defense observers. The engine in question is the F-91, a high-performance turbofan developed as part of Japan's ongoing push to create a next-generation fighter aircraft. On paper, the F-91 boasts capabilities that rival those of the US-developed F-119 PW-100 engine, which powers the F-22 Raptor. However, the F-91 remains a prototype, with no mass production timeline publicly confirmed. Japan's F-91 engine reportedly features a bypass ratio of 2.8, dry thrust of approximately 11 tons, afterburning thrust of up to 14.3 tons, turbine inlet temperature of 1,800 degrees Celsius, a total pressure ratio exceeding 35. These numbers place it at the lower threshold of what is typically classified as a fourth-generation jet engine. In aerospace terms, a fourth-generation engine generally meets two key benchmarks: a turbine inlet temperature above 1,800 degrees Celsius and an installed thrust-to-weight ratio exceeding 9. By these standards, the F-91 qualifies, at least in its prototype configuration. However, these impressive specifications come with caveats. The F-91 has not yet entered mass production. Historically, the transition from prototype to production includes trade-offs for safety, durability, and maintainability. A common industry assumption is that production versions deliver around 85% of the test bench performance. Applying this to the F-91 would downgrade its capabilities to what is considered third-generation engine performance. Much of Japan's progress in aerospace engine technology stems from its long-standing industrial cooperation with the United States. In the 1970s, Japan began assembling the F-100 engine, used in U.S. fighter aircraft, under license from Pratt & Whitney. This collaboration laid the groundwork for subsequent technology transfers. By the early 2000s, amid a period of American deindustrialization, the U.S. expanded its outsourcing of critical defense manufacturing. Japan became one of the key sites for producing core engine components, including high-temperature single-crystal turbine blades and advanced compressor parts for the F-119 engine. This background explains why Japan's F-91 closely resembles the F-119 in design and performance. The core mechanical elements of the F-91 appear to be derivatives or adaptations of U.S. technology developed during joint programs. However, one crucial element remains out of reach for Japan: full software control. The Full Authority Digital Engine Control (FADEC) system is a critical component of any modern jet engine, governing performance, efficiency, and safety. Despite decades of collaboration, the U.S. has not provided Japan with the source code for the FADEC software. Without this, Japan cannot fully control or optimize the F-91's performance, limiting its functionality and posing integration challenges for future aircraft. This lack of software access is one reason the F-91 remains confined to the test bench. Japan has projected that the engine will be ready for full experimental testing by 2033 and potentially integrated with its next-generation FX fighter program by 2035. But absent a domestic alternative to FADEC, mass production remains uncertain. The decision to transfer the F-91 technology to India appears to be driven by both strategic and economic considerations. Developing a new jet engine from the ground up is a capital-intensive endeavor. Without full software control or production capability, Japan may be seeking to recoup some of its investment or accelerate development by collaborating with another country. India, on the other hand, has long sought to advance its domestic engine manufacturing capabilities. Despite years of effort, India has struggled to produce a reliable high-performance engine for its fighter jets. Gaining access to Japanese turbofan technology, even in prototype form, could provide a significant leap forward, especially if India can pair it with its own or third-party control software. From a geopolitical standpoint, both Japan and India are positioning themselves as regional counterbalances to growing power blocks in the Indo-Pacific. Closer defense technology ties could serve their mutual strategic interests. This proposed technology transfer is not just a commercial deal. It's a signal, a reflection of shifting alliances, industrial dependencies, and shared ambitions. For Japan, it's a chance to keep its aerospace program moving despite internal limitations. For India, it could mark the beginning of a more self-reliant defense industrial base. Still, significant challenges remain. Mass production of the F-91 or its derivatives will require breakthroughs not only in materials and manufacturing but also in software. Whether this partnership can overcome those hurdles remains to be seen. As this story unfolds, it's likely to reshape how countries collaborate on high-end defense technologies, especially in a world where industrial capacity, software access, and strategic autonomy are increasingly intertwined.